Moving 6 million pounds of rocket off the Earth requires a massive release of energy. The Saturn V engines generated thrust with a ferocity that tore at the metal framework of the launch pad, creating shockwaves that rumbled for miles. This stack was the decisive technical conclusion of the Cold War. In July 1969, it turned the theoretical dream of lunar travel into a physical reality. This work was centered at the Marshall Space Flight Center in Huntsville, Alabama. In the early 1960s, Marshall was NASA's largest field installation, managing more employees and a higher percentage of the budget than any other center. But once the moon landing was achieved, the political urgency evaporated. Funding was slashed, and the defining mission that justified Marshall's massive scale simply ended. This created a dangerous paradox. The rigid, insular engineering culture that had successfully navigated the journey to the moon had become a liability, a threat to the center's survival in a post-Apollo world. To understand why Marshall struggled to adapt, we have to look at the origins of its engineering team. Years before NASA existed, this group developed the V-2 rocket during World War II. This history carries a heavy ethical burden. The V-2 was produced for the Nazi regime, and its manufacturing relied on tens of thousands of concentration camp prisoners performing fatal slave labor at the underground Middlework facility. Following the war, the United States recruited these experts to secure a strategic military advantage. Through a program known as Project Paperclip, Wernher von Braun and over 100 of his top rocket specialists were transferred to the United States. They spent their initial years isolated in the New Mexico desert at Fort Bliss. Living as wards of the Army, this group developed a fiercely independent identity, relying almost entirely on each other to solve technical problems. That experience birthed the Arsenal philosophy. It was the belief that the only way to solve complex engineering problems was to maintain absolute in-house control over every aspect of research, design, and production. This animated diagram illustrates their everything-under-one-roof approach. Instead of outsourcing work, Marshall kept research, design, and testing connected inside a closed loop, allowing experts to stay close to the hardware and each other. During Apollo, this model was highly effective. National urgency rewarded technical concentration, and the Marshall team was given the resources to maintain total internal authority. But the post-Apollo era brought deep budget cuts. NASA shifted toward a new model that relied on distributed external contractors, forcing field centers to manage private companies rather than build their own hardware. This caused immediate friction. Marshall's tradition of concentrated internal control was incompatible with a system where technical authority was spread across a network of outside businesses. To survive the austerity of the 1970s, the center had to begin dismantling the very arsenal identity that had made them successful in the first place. To avoid becoming obsolete, Marshall pursued aggressive diversification. They had to prove they were more than just a place that built giant rockets. They moved into managing orbital habitats, leading the development of Skylab. This required their engineers to master human systems rather than just propulsion. They also took on the propulsion systems for the Space Shuttle. While they kept their link to rocketry, they were now part of a reusable transportation system developed in a much tighter financial environment. Finally, they moved into big science management with the Hubble Space Telescope. By managing high-profile scientific instruments, Marshall proved it could remain central to NASA's future. This diversification saved the center financially, but it created new risks. Marshall was now responsible for politically sensitive projects where they lacked absolute control over every component. This exposure became a crisis during the 1980s. Because Marshall managed the shuttle's propulsion, the center was deeply entangled in the investigation into the Challenger accident. Their scientific projects faced similar scrutiny. When the Hubble telescope reached orbit with a flawed mirror, the center faced a public relations disaster that affected trust in the entire agency. These failures were public and national. Without the shield of their old, self-contained arsenal system, Marshall had to operate under intense scrutiny and accept a new level of institutional accountability. Dramatic missions provide the public milestones of exploration. But the program is sustained by institutions that can endure changing political and financial climates. Marshall's 30-year trajectory demonstrates that long-term survival in space relies on an organization's capacity to repeatedly reinvent its own technical identity.